Section 2.4 is on page 120, talks about trigonometric identities. And here we're going to talk about the identities that we already know. That is, cosecant of theta is 1 over the sine, secant of theta is 1 over cosine, cotan is 1 over tan, and vice versa, of course. Sine is 1 over cosecant, cosine is 1 over secant, and tan is 1 over cotan. We also keep in mind that tangent has another identity. Instead of 1 over cotangent is sine over cosine, and vice versa. We know that trig functions are odd, except for cosine, it's the only even function. That's the best way to remember it. And of course, the tan and the cotan go hand in hand, the sine and the cosecant go hand in hand. And the Pythagorean identities, those sine squared of an angle plus cosine squared of an angle equal 1. Like we said in class, if you divide this equation by sine squared each of those, sine squared over sine squared is a1, cosine squared over sine squared is cotangent, and 1 over sine is the cosecant. And if you go back to this first identity, and if you divide everything by cosine squared, sine squared over cosine squared is tangent squared, cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. Those are the first set of identities that we're going to be playing with. Identities means the same value, equivalent. So, we're going to jump and start looking at from number 21 to 100. Oops. And that is on page 126 in our book. And directions, establish the following identities. What this means, show that those two are the same. Now, you are allowed to work with one side. You look at both sides and you kind of glance at it, say, okay, which side looks more complex? That's the side you want to start with. Theoretically, you could start with either side and get the same answer. But if I look at this, I notice that this is a secant. I know secant is 1 over cosine of theta times sine of theta. And I know this is the sine of theta over cosine of theta. And I know that's the tangent. So the goal, if you start with the left-hand side, is for you to get the right side. Keep in mind, I keep this in mind as I do the problem. That's going to help me to get to where I want. Now, problems in identities, depending on the section. In this section, there's one of two things you look for. Either you look at the identities and figure out, are they squares or are they not squares? If they are squares, then I'm going to use the Pythagorean identity, and that would be those three. And if they're not squares, most likely I'm going to write everything in terms of sine and cosine and simplify. And that should do the trick for most of the problems. Simplify means if I see a fraction, get a common denominator. If I see a complex fraction, clear the denominator out, make it a single fraction. If I see a chance to factor, I would, if I look at number 24, there it is. I would say this is 1 plus the cotangent of negative theta squared. That is 1 plus. We know cotangent is an odd function, but when I square a negative, it becomes a positive. And I know that 1 plus cotan squared is the cosecant squared of theta, and it's right there. So you work with one side until you get the other side. You're not supposed to work with both sides, only one. And if I look at number 28, again, identity means show that those two are the same. Sometimes at first glance you're like, oh, well, that could never be equal. Well, don't be so sure. So I glance at those. I notice the right side is only sine squared. So I'm going to start with the more complex side all the time. I glance at that and say, okay, well, there's not much I could do with that. So I could go for sine of u, and I notice there's a cosecant. I know cosecant is 1 over sine. And those cancel out. I'm left with 1 minus the cosine squared of u. And I know 1 minus cosine squared of u is the sine squared of u. So keep in mind how this identity, even though it says sine squared plus cosine squared equal 1, the majority of the time I use this, I use sine squared of theta to be 1 minus the cosine squared of theta, or I use cosine squared of theta to be 1 minus sine squared of theta. This is pretty much how I use this most of the time, at least in this section. The next problem I want to look at would be problem number 34. So I'm picking diverse set of problems to kind of touch on every combination you can see. If I glance at this at first glance, you're like, well, I need to get a 1 somehow. Well, let's see. Do I know what 1 minus the cosine squared is? Yeah, that's the sine squared of theta. And do I know what 1 plus cotangent squared of theta? Isn't that secant squared of theta? I'm sorry, cosecant squared of theta. Okay. And you could see it right there. You see that 1 plus cotangent squared, it's right there. That is cosecant squared of theta. So, isn't that sine squared of theta times 1 over sine squared of theta? Well, those cancel out, and guess what I'm left with? Now, on your test, you're going to show me all the steps. I need to see everything that you're doing, and no matter what you do, I'm going to follow the steps, so make sure that you're writing every step so I could follow easily. Those are among the toughest to grade because no matter what you write, I need to follow, because, you know, I see the problem one way, you could see it a totally different way, and we could both be correct. I'm looking at this problem and I'm not sure what to do. So I noticed, well, oh boy, which side do I start with first? I'm going to start with the left because they look equally difficult. But keep in mind, even though I'm going to start with the left, I noticed the right side consists of only cotangents. There are no cosecants. But I notice cosecant squared is common in both of those. Can't I factor that out? So normally, the way this works, if I see factoring common denominator, you know, two fractions, complex fraction, pretty much that does the problem, or at least gets you started. Now when I do this, I say, okay, not a problem. This right here, I have to adjust the screen so I could run back and forth. This right here, cosecant squared of theta minus 1. There's cosecant squared of theta minus 1 is actually, all of these errors are making this a big mess. But if I look at cosecant squared of theta minus 1, isn't that cotangent squared of theta? And isn't cosecant squared of theta cotangent squared of theta plus 1? Now you might be thinking, how did I know to do this? Well, you know, I'm very smart. Or I looked at the other side actually. I saw there were all cotangents. I knew exactly what I need to do. And if I distribute this in, cotangent squared times cotangent squared is cotangent to the fourth, and cotangent squared times 1 is cotangent squared of theta. And there it is. Once I get the other side, pretty much I'm done. And that's the goal every time. Like a puzzle, except you have the problem and you have the answer. You just have to be patient and work with what you have. A bit of algebraic manipulation will do the trick most of the time. If I look at number 46, for example, at first glance, I might be thinking, oh boy, how the heck am I going to show those two are equal? I can't fit that there, that's okay. But if I look at this, I'll notice that the right side is sine, the left side is cosecant. Can't I write this as 1 over the sine of v minus 1 over 1, 1 over the sine of v plus 1 over 1? A complex fraction, isn't the LCD for the top and the bottom combined sine of v? So if I multiply this by sine of v top and bottom, wouldn't this be a single fraction? If they all have the same denominator, you ignore the denominator completely. That's like multiplying by the reciprocal. That will be 1 minus the sine of v over 1 plus the sine of v. And guess what? That's pretty much it. So normally, if I could get a common denominator, clear a fraction, that's pretty much where you start. If I look at the next problem, I'm looking at number 52. And if I ask which side do you think is more complex, well, obviously the left side is more complex. Look at that. And what can I do with that? I can get a common denominator. Isn't the common denominator 1 plus the sine of v times cosine of v? And I'm going to multiply this by cosine of v top and bottom. And I'm going to multiply this by 1 plus sine of v top and bottom. So on the top, I'm going to get cosine squared of v plus, and if I FOIL this, I'm going to get 1 plus twice the sine of v plus the sine squared of v. And this is going to be 1 plus the sine of v times cosine of v. Now, I did want to mention, I go on the side, and I recognize that this is 2 over the cosine of v, so I know I'm going in the right direction. Now, when I look at this, what does cosine squared plus sine squared equal? Isn't that a 1? Plus 1 plus twice the sine of v, and those add up to 2 plus twice the sine of v. And if I factor a 2 out of the top, wouldn't that be 2 into 1 plus the sine of v over 1 plus the sine of v times cosine of v? And what do you know? Those two cancel out. I'm left with 2 over the cosine of v, and that is twice the secant of v. And what do you know? Magic, right? No, it's math. And I'll go back and erase this, and guess what? My teacher will never figure out that I did this. So it's important to know where you're going, right? You're not supposed to work with both sides of the equation, but it doesn't hurt to glance. That's not a problem. That we all do it. I'd like to look at problem number 60 next. Number 60, I'm trying to figure out which side to start with, and you can't go wrong on that. I am going to choose to go with the right side. The reason for that, if I see that I have sines and cosines and anything other than sines and cosines, I would start with the other than sine of cosine, because I could write this as the sine of theta over cosine of theta, and 1 minus sine squared of theta over cosine squared of theta. So at least I know where to start. If it's not sines and cosines, I write 1 over, I come up with a fraction, or that sort of an expression. I'll find the LCD, and most likely that's what it is. The LCD between cosine and cosine squared is cosine squared of theta. This is missing a cosine. This is missing a cosine squared of theta. So I'll notice that the denominators cancel out because they're all the same. I read the top. The top here is cosine of theta sine of theta, and the top here is the cosine squared of theta minus sine squared of theta. And what do you know? That's pretty much it. One step and I got there. And that's how most of these work. I want to do a few more just to make sure I touch on everything. I have to do that in the second video.